Okay. And this is a quiz, so make sure. Okay. Use the acceptable table. Or construct the exponential shape in a 4x4 rectangle. Okay. Now you don't have to go any further than that. You don't have to read the rest of it until you construct that table. If you're doing a problem on a test, if there's something it says to do in the first step, well, you can read ahead, but you don't worry about what comes next until you've done this first part. Okay? Then you can worry about the rest of it. So let's get that constructed and then see if you can do the rest. Okay. Now, I gotta say, if you're not making it to all the classes, unless you got a medical situation or something like that, and if you do, let me know. But need to practice these things until you can do all 5 of the toolkit functions in 10 minutes. We had a quiz on that last time. Only one person did it. A couple others got fairly close. So, but only about 3 people made what I consider a passing grade in the quiz. And next week, we're going to have a test where you're going to have to do these things. And it's going to be in the testing center. You're not going to have any notes. You're not going to have pictures. You're going to have to do it quickly. Okay? So everybody is making some mistake on sketching the exponential function, meaning that you haven't practiced it enough, or maybe you're just having a bad day because some people made a mistake on it that didn't write the last couple of classes. Okay. So we can't even talk about this. Can't even talk about how we use these graphs, which you were supposed to have been able to do quickly 2 weeks ago. You have to practice. And you have to practice with a timer until you can draw all 5 of those graphs correctly. Once you've drawn them correctly, what I recommend is, and I said this before, and I'm wasting a lot of class time saying it, and I have to say it again. And of course, this means I'm taking time away from helping you prepare for the test. We have to get this stuff done. And it only takes practice. You have the videos. Repeatedly, I've shown you how to do this. You can find it in the videos. I'm not going to explain it. I'm just going to go on. Okay? I've written it out. You have it on your assignments page. You have documents that have these instructions. But I recommend, and I think I've got this recommendation on the assignments page, is you draw each one. You can draw it with pictures and the directions in front of you. Do anything you want to. Get it drawn. Okay? Then put the instructions and the pictures away and see if you can draw it. Then compare it with the instructions and the pictures. If you drew it right, great. Draw it again. And keep drawing it until you draw it 2 minutes. Then go on to the next one. Then come back and draw all 5. Okay? And see if you can do that in 10 minutes. That's how you prepare for a quiz. It's worth 30 points, which is a significant number of points. So what I'm saying in class is I'm saying really good aptitude. I'm seeing people that are, most people are doing it quickly, learning it quickly, but not following up. Okay? There might be things in your life that just prevent you from spending the couple of hours that I've asked you to spend in the last 3 weeks doing this, okay? You have to be able to do this. You will not pass a course, you can't do this. And it's achievable. All you need to do is practice. Okay? You're having a terrible time with it. And I don't see anybody, well, yeah, there are some people maybe having some really difficulties with it. But you know what's going on. Why is it? You're not looking at the videos. You don't have to look at the videos. Okay, you're not looking at the videos. They're written instructions. You've done it in your notes. If you've been there. You've done it in your notes if you viewed the videos. Okay, and again, you know, half the class isn't here today. So I'm a little concerned. Now, there are people who I know are doing quite well. Okay, and people are gonna do quite well. You're only gonna do well if you follow up and do the assignments. Okay, well. That, here's a different. There. Would that take 20 seconds? Okay, now I'm giving you 2 minutes. Okay. Now, if you don't know the rules, you can't do that. If you draw too many lines here, it's not gonna work. Okay? And the instructions are very explicit. Now, the point is, if you practice it, you're not gonna draw too many lines. Okay? And if you practice it, you're not gonna start here, you're gonna start here. Because if you start here, it's not gonna work. You're not gonna end up here. Now, you could end up here if you only do 3 lines and start at the lowest one, but you'd end up here. Okay, so you get immediate feedback if you're doing it wrong. And it doesn't take long, as quick as many of you appear to be. It's not gonna take you 2 hours to learn, it's gonna take you half hour. Okay? I think almost anybody here can do it if they spend 2 hours on it. It's worth spending 2 hours in the last 3 weeks to learn the this. Okay. So I'm concerned about it. You know, follow the workouts. Okay, still. Most of you have the rhythm, you just got to get the music. Okay. The details, you got to keep drawing these until they're right every time. And if you draw them enough, you're not even going to be able to draw them wrong. Okay. Okay, so there it is. And of course, we have the real dot. Okay. So the coordinates of the red dot are negative 12, 20. Rectangle is 4 by 4. It's actually a square, but squares are rectangles that have equal sides. 4 units here, 4 units here. So what are the coordinates of each of these 5 points? Okay. This line here is x equals negative 12. Okay, now we've done this, so make sure you review it if you need a longer explanation. It's there in the videos. We've done it a number of times. We label all the construction lines. Now, I didn't include labeling the construction lines in the instructions here because it's automatic. If you need them, you want to label them, and if you want to get these coordinates, you need to label the construction lines. These dotted lines here, and as well as those lines. Now, okay, x equals 12 on this vertical line. Everywhere in this vertical line, x is 12. So what's x here and what's x here? This is 4 units wide and this is in the middle. Okay, and the fact that this rectangle is 4 units wide and x equals 12 occurs in the middle, you should be able to figure out what x is here and what x is here. And that's critical, so I'm going to ask you to just write down those 2 numbers and circle them on your paper so I can tell if you're getting it or not. Okay, very difficult to do this without understanding certain finite things. X is the same everywhere in this line. If X goes this way, Y goes this way, this is fundamental to the whole idea of the coordinate plane. We have the same X at every point on this line. That means I mark this point, the X value is whatever it is here. I mark this point, I mark this point. The X is always whatever it is when we cross the X axis. Okay? Does that make sense? It really needs to make sense. So don't get go back this video and listen to this explanation, please. And at every point here, Y is the same. Quickly, very quickly, sketch an X and Y axis and sketch a vertical line. And put a few X's on it, a few points, mark a few points. Do that like in 10 seconds. Just an X and a Y axis, vertical line, and mark a few points in that line. Okay, now mark or sketch a vertical line for X is greater or bigger X. Okay, let's pretend on your line that X is 6. Can you sketch me a line where X is 8? So label one of your lines X equals 6 and the other one X equals 8. Okay. Now this line is X equals 12. How far is it from this line to this line? Show me with your fingers. This line is in the middle of a 4x4 rectangle. Okay. This line is half the width of this rectangle to the right of this line. Okay, can we see? Because this is, we have to be able to see this. If this is 4, then we have to draw this. This is 2. And this is 2. So this line is 2 units to the right of X equals 12. Okay. What is X? If you're 2 units to the right of X equals 12. Write it in your paper. Just label this line and then label this line 2 units to the right. Okay. And I said X equals 12 here. I don't think that confused anybody. I think everybody had it right. I just realized I didn't write it correctly. But it's just X equals -12, right? Now, 2 units from -12. Can we count from -12 up to 0? -12, -11, -10, -9, -8, -7, so forth, right? Now, if we count 2 units over from -12, we go -12, 1 unit would be -10, 1 unit would be, 1 unit would be -11, and 1 more unit would be -10. It's 2 units between -12 and -10. And if we go this way, we're counting on, we're going further into the negatives. So it's -12, -11, -10, -12, -13, -14, -15, and so forth. So for -12, well, this is 1 unit here. So this would be -13 and this would be -14. Okay, so what would this be? What would this be? Well, we can't have any more time working this out. And it's pretty clear that this is -11, this is -13. So we're going from -10 to -11 to -12 to -13 to -14. Okay, now on this scale, y equals what here? Y equals what here? Y equals what on this one? Now, let's just start with this one here. At the bottom, y equals what? And at the top, y equals what? What's y down here? Right on your paper. Okay, the first thing we have to see, of course, is that the red dot is at y equals 20, so that this line through the lower edge is y equals 20. Now, it's a 4x4 rectangle, so that this line is 4 units higher than this. What's 4 units higher than 20? It's 24. Okay. Now, this line is supposed to be halfway between here and here. Because that's your algorithm, you go halfway. Now, when I did it, yeah, I made that line a little bit higher. Remember, I drew this thing very quickly, but still, you get the general idea. Halfway between 20 and 24 is what? 22, right? And we can see that if we have to calculate it, you can calculate half of 4 and add it to 20. Okay? And find that this line is 2 units higher than this one, which puts it at 22. Now, this line is twice as close to 20 as it is halfway from 22 down to 20. Halfway from 22 to 20 is 21. Halfway between 21 and 20 is 20 and a half. Halfway between 20 and a half and 20 is 20 and a quarter. In other words, this distance is 4. This distance is half that, which is 2. This distance is half that, which is 1. Half of 1 is 1/2, and here's where 1/2 comes from, and half of a half is a quarter. Now, we've been labeling these things for well over a week. Okay. And I didn't realize until today that people would have so much trouble understanding these numbers and these coordinates. So you got to get over that. You got to be able to do this, because if you've read the handout I gave out last time, and people were here last time, but or look at the assignments page where you have 100 versions of that handout. Okay, with different numbers and different, but the same patterns of problems, so that you can prepare yourself for the test by making sure you can do these problems. You have to be able to do this in order to answer the question I started with. Make a table for the points you use. Okay. So I would have thought that it would be pretty automatic to do this, but obviously people are not getting a good introduction to the coordinate plane in their prerequisite courses. And it might be that's just not even in the curriculum for Algebra 2, but I can't imagine that. Still, once you see it, it's easy. So just make sure you see it, okay? Now, table for the points. Okay. And what I mean by table for the points? I mean. Um. I think almost all the graphics was more. Okay. So what are the X and Y coordinates at this point? Just take the table, write the X coordinate here, the Y coordinate here, for every one of these points. For example, if you had a point here, you don't, but if you had one, what would X be? Well, it would be -13 because it's on the -13 line. Okay. What would Y be? Well, this point is on the line Y equals 22. So this point would be -13, 22, right? Now, once you can get these numbers, this is easy. You just look at the two lines, the numbers for the two lines, the X number and the Y number for the two lines that intersect. Because every point on every one of these graphs that you're asked to construct lies on the intersection of two construction lines. Okay. So what are X and Y? For the 5 points, make me a table. Okay. So this point X is -14 and Y is 20 1/4. Here, X is -13. If you got these labeled, you can read it off. You can also make sense of it, that it's -12 here and one to the left is -13. And it's 20 1/2. And then it's -12, 21, -11, 22, -10, 24. Okay. Now, I would ask you to write the equation for this, because we did this 2 weeks ago today. But I think not seeing this, I was going to tell you what the equation is. What I do on the third group of problems. I ask you to do this for one of the functions, exponential squaring, reciprocal square, reciprocal, or cubic. Yeah. And I'll tell you, I'm not going to use a cubic function on the exam, except maybe a question. Well, the first question asks you to draw 5 graphs. You have to draw. But the cubic function behaves a little differently because you don't do it in a 4x4 square. And you do it in a 16x4 square. So we'll stick to 4x4 squares. No, we're not. Okay, here's your table. The function has this form, except that in this case, A equals 1 for this rectangle. And A will also always equal 1. Okay. Now, our function f of x is the exponential function. f of x equals 2 to the x. Now, 2 weeks ago in the video, I listed all 5. A, f of x minus h plus k functions. And we went over function notation, and how function notation works. Make sure you know that. You're gonna need it. Okay, anyhow, f of x equals 2 to the x. So f of x minus h equals 2 to the x minus h. Why do I do that? I do that because of this. Now again, if f of x equals 2 to the x, then if x is replaced by x minus h, this x is replaced by x minus h. You should be very familiar with that because I've said it about a million times, but not for the last week or so. So maybe your memory needs to be refreshed, which is what we're trying to do to prepare for the test, okay? So if you don't understand this, go back and review it. Okay. If x minus h equals 2 to the x minus h. And it follows then that a f of x minus h plus k equals 1 2 to the x minus h. These coordinates are h and k. The red dot is at hk. Again, said that a number of times. You weren't here. Make sure you thoroughly not just viewed, but engaged with the videos. By engage with, I mean, when I ask the class to do something, you stop the video and do it. And then you listen to my explanation, and hopefully you got it, so you can get quickly through my explanation. Okay? If you're not doing that, you're not gonna learn it as well. Now, maybe, you know, you're really good, and you have a really good background and so forth. You can pick it up by just viewing it, but I wouldn't count on it. Very few people can do that. You have to engage with it. You have to stay active. Otherwise, you sit back like you're watching TV and you just absorb whatever you want to absorb and get entertained. Okay? Not that you're going to find my videos all that entertainment. This is what you get. Review the videos so you see. Okay, now on the third group of problems, I'll tell you what the function is. On the fourth group, you're going to have to tell me what the function is. See that on the handout. So now you could make a table for G of X. Using the numbers -14, -13, -12, -11, -10. Start with x equals -10. Write out this expression, g of x equals 2 to the x plus 12 plus 20. And then below that, write what you would get if x is -10. In other words, much more going on here. You write g of x equals 2 to the x plus 12 plus 20. G of -10 equals negative, yeah. Actually, let's do G of negative. No, let's do, yeah, we'll do G of -10. Okay. G of -10 equals what? You need to write that out more neatly. You look it off the bottom. Can you see it? Okay. Okay, so our task right now, don't be down to anything else. Write this expression, then write G with a -10 in parentheses, and complete it. I've written this a little bit smaller than I probably should have. I'm trying to keep everything on the picture. I guess I could have zoomed it. Move this over and write it a little bit. This is really important. Okay, there's your G of X, the same as what I wrote there, same thing. So G of 10 to -10 is what? X is replaced by -10. And -10 plus 12 is 2. And we get 24. We write 24. Then G of -11 is -11, 2, and then -11 plus 12 plus 20, which is 2 to the 1 plus 20, which is 2 plus 20, which is 22. G of -10 is 2 to the -12, sorry. Is 2 to the -12 plus 20. -12 plus 12 plus 20, might be getting hard to read. You're going to get 2 to the 0 plus 20. If you think 2 to the 0 is 0, you're in the water. It's 1. And I went over that by writing decreasing powers of 2, showing the pattern. Showing you why it has to equal 1. Also has to equal 1 because this has to equal 21. Okay, now 2 to the -13 is going to be 3.5. 2 to the -14 is going to be 20 1/4. Make sure you know how to do negative exponents. The rule for negative exponents that I'll write down here. Do not forget this, you're going to need it. So you can always use a calculator to evaluate these on the test. But you're going to have to justify them on future tests. You're going to have to make these rules. A raised to the -b power is 1 divided by A to B. The B goes into the denominator and you lose the negative. Has to be that way for reasons that I've explained. Okay, so you should be reviewing. And now it appears I wasn't getting the bottom line, but okay. Now you notice that this table matches this table, which is what should convince you, as we've done since the second day of class, that this graph is represented by this function. Okay, validating the A f of x minus h plus k, or at least the f of x minus h plus k. It works. You have to be able to write that for all 5 of the functions that I've listed. Now I'm going to This one again, just very quickly, and I'm not even gonna read it to you. Yep. One of the problems. Deal with. Okay. Continuing minus bonds, log square exponential reciprocal 60 square cubing. Go to the video, you can't read it. Okay, but I'll try to write it. There they are. You gotta memorize them, memorize them. But easier to understand the pattern. This is the x squared function. This is the 2 to the x function. This is the 1 over x function. This is the 1 over x squared function. And this is the x cubed function. Basic toolkit function goes in this column. A F x minus h plus k goes in this column. Put this on the board 2 weeks ago today. People saw the pattern. We use that pattern to begin understanding function notation. Make sure you're conversant with that explanation. If you're not, and if you don't really understand the function notation, then memorize these. Look at the pattern. Look at what these functions are. You should know what these functions are. That's easy. You know, square, x squared. Exponential, x is in the exponent. Reciprocal, 1 over. Reciprocal. Turn it upside down. Reciprocal squares like the reciprocal, they just square. Cubing, or cube x. Okay, so the names go in a pretty obvious way with basic toolkit expression. Okay, let's say function, when it actually changes word to the expression. Okay. I'm gonna leave this out here now. Okay, what function did I just mark off then? Which one of these? It's one of the five. Okay, this is reciprocal square. If you're practicing these, you're gonna recognize it. If you haven't been practicing these and you recognize it, that's really good. Just practice so you can do them correctly and quickly, okay? This is reciprocal square. The rule is do 3 steps subdividing toward the center. First step is the center. Second step, you go halfway from the edge to the center. Third step, go halfway there, and you end up with 5 vertical lines spaced as you see, and it should be obvious what I mean. Okay, and then you divide it vertically, top edge toward bottom edge, halfway, 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 until you got 4 lines. You start on the left edge on the first of your construction lines, not on the left edge. People want to start here, you start here. For the exponential function, you start here. For the reciprocal square function, you start here. You never start here. Not in the 4x4 rectangle, okay? Now you would start at this corresponding point if you're making a cubic function. Cubic function goes corner to corner. Okay? No other function does. Then you sketch it line and you make sure, absolutely sure that you don't try to connect anything on the left, anything on the right. I've explained why a number of times. It's because you keep going halfway. And if you go 4 times as high, you never get to the center. From the right, you never get to the center. From the left, you never get to the center. So if you try to connect left to right, you go through the center and you have a point on the center and you can't have one. That's worth digesting. But right now, just understand you don't connect left to right. Or the reciprocal square function. Where's the red dot in the reciprocal square function? Well, it's something kind of really. It's here. There's the red dot. Okay. Now, the reciprocal square function. A lot of dumb things today. Okay. The reciprocal function would be the. Okay. There it is. Now, this point is HA. What's the function? Of course, I still have some semblance of a simple balance. Could wipe out this table and everybody sitting at it. Okay, it'd have been a terrible day. Actually, I probably would face planning before I got the table. Okay, HK. And reciprocal square function. With 1 over x squared to the base of toolkit. It's a times 1 of the x minus h squared plus k. That doesn't work just in a 4x4 rectangle, just a little preview. If this was an 8x4 rectangle, well, 8 is twice as big as 4, so A would be 2. Okay? So for these 4x4 rectangles, A is just the height divided by the width. You don't need that. I'm not going to put that on the test. That's the first thing we do. Okay. Won't be responsible for it on the test. Okay, well, right there it is, and all we do is we replace x by x minus h. We add k onto the end. We put an a out in front of the thing we do when we replace x by x minus h. That's function notation. Well, we think of it in terms of function notation. We first figure out what f of x minus h would be. If f of x 1 over x squared, and if we replace x by x minus h, we get 1 over x minus h squared. And then a times that is there, and plus k. That's all there is to it. So there's the function. Oh, well, if I ask you, as I would on the fourth problem, to construct one of these functions, I'll specify which one, maybe it's a reciprocal square, then you would maybe construct it, maybe I don't even ask you to construct it, I just ask you for what the equation is. Okay, so if I ask you, if it's a square and 4x4 rectangle, with the red dot is 793, 546. First place, you'll be able to do everything we did over here with the exponential function. You draw the rectangle, you do the lines, okay? And then you have two to the right of 793, your right line would be 795, your left line would be at 791, okay? Your lower line would be at 546 on the Y, and upper line would be 4 more than that, which would be 550. So you could put to do that. Here X equals 791. Here X equals 793. Here X equals 795. Here Y equals 546. Here Y equals 550. And then your other lines, well, it's going to be 792, 792 and a half, 793 and a half, 794, and so forth. Okay. Yep. If you understand what we did earlier, you can do it no matter what numbers I put here. A 4x4 rectangle, you just go 2 more, 2 less than this, and you go 4 more than this, unless the rectangle is for the reciprocal square, in which case the red dot's at the middle, and you can figure out what's wrong with that. Okay, you just use common sense with the numbers. Now that's more of a challenge than I expected it to be. It's not too surprising because you haven't really ever thought about numbers. You have never really had to think about numbers. You just put them into your calculator and get them. Okay. And if you draw a graph, you're provided with a grid. So all you do is mechanically plot points rather than thinking about what you're doing. Okay. We're trying to make a transition here, thinking at the pre-calculus level. And we really have to start. I mean, we've done a significant amount of pre-calculus already, but now we've got to combine it with the algebra and the formality of the first chapter in the text. Okay. And if you know this, that's going to be pretty easy. But the algebra, you got to think about the numbers. Okay, well, that's why we're doing what we're doing, trying to get the numbers, trying to use. Okay, yeah. Draw the rectangle, label the lines. Then you can make a table. Okay. Then you can compare the table with what you get from this function. Now, I generally say f of x is your basic toolkit function. And q of x is a, f of x minus h plus the a. And now that we know what the function is, we know what to do with the x minus h and the k and the a. Okay. It's a very simple pattern. All you got to do is practice. If you practice this for an hour, you're going to get it. Right. I mean, I see y'all are plenty smart. Most of you, I'll practice this for an hour and get it right. You'll understand it well enough to do this on task. Okay. Now I was quickly go through. Oh, so very first problem. It might not be the first problem you test. I might scramble the order. Okay. But you're gonna have a problem like the very first problem, the 0, 0, 1 problem, where you have to sketch all 5 graphs. That shouldn't take you long. If it does, just plan on being in there longer. Okay? You should actually be able to do it in 5 minutes, but it's gonna take 10. That's okay. I'm thinking 10 minutes of a problem. There is a 6th problem. And I'm not gonna be able to talk about it today. Talk about it Tuesday. From Tuesday, you have a week. So you will have time to prepare it, but that means you're gonna have less time to talk about the homework assignment that you're gonna do in open math. And I'm not gonna be able to prepare you for that, but that's something you should be able to do. If you understand what we do here, you should recognize it. And then I'll see how you do in homework and talking about it on Tuesday. Okay. Okay, now. First problem, you're gonna draw, that's gonna be, okay? Then. Just asking you to sketch these things in a 4x4 rectangle with the red dot at the origin. We did that last time. Review from last time, you know. Have that. And it's simpler than this because that's 0, 0. So that's clearly x equals 2 and x equals -2. Y equals 0, y equals 4. And it's pretty obvious what the length would have to be. And you should be able to do that well, since we did it on Tuesday. Okay, and if you do that well, then it's not too hard to do this if you got 793 and 546. Okay, you're not gonna see numbers that big, but if I gave you numbers that big, it wouldn't be any harder. Give you a number 7,294,586.7. Okay, and you could do it. Okay. Have to give you 2 numbers. Okay, then, and the next one, what do we do? Just pretty much what we did here. You construct it. I tell you what the equation is, and you verify it by plugging in. Okay. Next step. We get figured out these things. I printed these things in 2 seconds. You know that. Next problem is where you tell me what the function is, just what we're doing here. Okay. On the next one, we can find it. I ask you to sketch a completely labeled fundamental triangle between 2 points of the graph. We did that in class. It's been a little while, but if you've reviewed things, you can have it in the forth. But I'll show you. For example, if I said the completely labeled triangle between this point and this point. Okay, that means we draw a line between the 2 points. We draw a path from this point, this point, straight over, and then to this point straight up. This side is called the rise. And the rise is 550 minus 546 1/4, which is 3 3/4, which you could write as 3.75. Okay. In other words, just how long is this line? And is it up or down? If it's down, then the rise would be negative. And the run is 792 minus 791, which is 1. And then the slope is rise of the run. Equals 3 3/4 divided by 1. And that's just 3 3/4. So we write 3 3/4 here. We put a box around it. There's a completely labeled fundamental triangle. That's a quick review of what we did in some detail last week. Okay, so that'll be able to do that. And the slope of the triangle is the average rate of change of y with respect to x. Well, that's really easy if you draw the graph. Okay. And if you can make estimates, I talked about making estimates. We might review that on Tuesday. And then you have domain and range. Quickly. On the same function, here's your square function. The domain consists of all the points you get. Draw vertical lines through points of the graph. It's all the x values. So the x values go from here to here, and then from here to here, but there's a gap because there are no points in this rectangle that have x values between this one. So for this function, using 793 and the 596, we include the points at the end because they're points. This is the interval 791, 792.5. That's on the left. Union with the interval 793.5, 795. So I kind of want to see the graph, and I kind of want to see some lines down here, and then you darken the part of the x-axis or the lower edge. Okay, and you've got your lines labeled, so it's all in. And the range is a set of all the y values. And the range would be from your lowest line up. $546.25 up to $550. It doesn't go from the bottom to the top because there are no points lower than this first line, not within the rectangle. That would be the domain and the range within the rectangle. And if there were points over here that gave you different lines, then I just drug it, include them, so I could actually draw points. But it wouldn't add anything to what the range is. Make sure you can do that for the reciprocal square, and the exponential function. Do one of those three. Okay. Now there's a sixth problem, an application problem. Read the assignments page and view the 15-minute video I tell you to view. Then we'll talk about it on Tuesday. Should be easy problems.